Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. Today we have another unboxing experience, and as ever, Kaiweets are smashing it out the park with these things. These are relatively cheap multimeters that you can get in all the usual places like Amazon and whatnot, and they have phenomenally high reviews. And you may have seen in previous videos, I've started using quite a lot of the Kaiweets brand. It's kind of a weird name, and you kind of don't associate it to the usual brands like Fluke or my favourite Isotech. But yeah, they're really doing everything you need to do. I call coming from the Far East, they're doing a good job at it. And one of the problems I have with my Isotech is that it doesn't do current. I use this day in, day out, and I even have a spare one just because they're so great. And it doesn't do current. And at the office today, we couldn't use any of the multimeters because they'd run out of 9-volt battery. So it's just absolutely maddening. I do wish I had these with me at the time. So what we have here is a clamp meter. We have a digital smart multimeter and a test lead set. So each of these has their own strengths and weaknesses, and we're going to go through them briefly. Again, I haven't actually tried these out, but I can tell you though, this is something I'm very excited to look at. So we'll have a look at the digital multimeter. Again, I have glanced through it. There are some very good pros on this, and we'll see if we discover any cons. Good thick manual, by the way. If you are into nice big manuals we've got on there, although of course it is in 24 languages. I tend not to use manuals on multimeters, which is obviously a very dangerous thing. However, I think this has features on it that make it very good to the beginning multimeter practitioner. And when I did look on Amazon today, they were there for about £45, which honestly, trust me, is as cheap as chips for a meter of this quality. Right, so first things first, you do come with a charging label in the kit, which is fantastic because it is got a lithium battery in it. And look at that, a little torch on the back, so nice, so many features. That's got that benefit because you will never have a 9-volt battery, one of those PP3s when you need it. There's your thermocouple so that you can actually measure temperature off it too if you want to do temperature measurements. And it says it's a true RMS, 10,000 counts. Gosh knows what that means. Let's look at the bottom here. You have 1,000 volt input. Oh, sorry, max 750 to 1,000 volts of AC there. On the current measurements, you have 630 milliamps between those two, and then on the amp side you have 10 amps. So it's a pretty decent range there. So if you're trying to measure something like, you know, some DC motors and things like that, you'll probably be able to do it. Don't do your washing machine motor. I think you might start exceeding the limit there. It does have this shiny screen, which I just off camera have tried to wipe and made a mess of it, so that might be something that could annoy you, so make sure you've got a lens cloth for that. So let's turn it on, and I'm going to shut down the lights, I think, because it is a kind of reverse illuminated display. So rather than being black on white, it's a colour, and it's re-illuminated. It does have an auto sensing mode. I was playing with that earlier, so you can see it's basically bobbing around looking to see what mode you might want. But if you want to hard set it, again, like the other Kaiweets meters, you can just explicitly set it to what you want. So for example, there's your voltage, and it's saying DC at the minute, so that's interesting. I'm not quite sure how you switch between AC. Sometimes you hold down another button or it figures it out itself. There's your current, there's your continuity. You look diode, capacitors, millivolts, different range there. Frequency in hertz as percentage, temperature, NCV live. I think that may well be mains testing. Again, we have to start looking in the manual for that. And then you're going through your higher current range. But you might have noticed as I'm switching through these, it's telling me at the bottom what set of inputs I need. So that's what's saying it might be good for the old beginners one because it's telling you. And to be honest with you, that can confuse you. And if you get it wrong, sometimes, you know, you're trying to measure a current, you have it on the wrong setting, you can blow up your meter, which is very annoying. And look at that, I held the button down on the back, turns on the lights. That's pretty neato. Let's put some probes in it. So I'm going to leave it back into auto. I've got a bench power supply next to me. So this could be the sort of thing that you might want to test, for example, a jack. And I'm going to set that bench power supply to a known voltage. So it's saying 9.02 volts. So let's see if we can put this back into the auto range. Yep, there we have. I just held down the button and you see it's flashing these two down there. So black goes into the common, red goes into the input. I'm going to hold this on the outside edge. Now this isn't mains, so it's not going to kill me, but you can see they have these shrouds over there. So that's protecting you from the high voltage. It says it's category 3, 1000 volts, category 4, 600 volts. So that should protect you, and remember, don't really put your fingers beyond that. But we're measuring a low voltage thing here, so I'm going to pop them off. But we'll have a look to see what it is like in the light. Yeah, you can kind of see that there is reflectivity on it, but it's still pretty readable. So I'm going to hold that there, and we're going to hold that there and see what happens. And has it worked out? Well, not yet. I think I've knocked it out of the auto mode. Let's put it back in. Nope. I guess holding it down. Oh, no, there we go. So you can see it is in volts, and I'm just going to, I will knock that off actually because I'm trying to look at it from a certain angle, a different angle to you. And you can see it's saying 9.02 volts, and that's exactly what my bench power supply says. I will turn the bench power supply up right up to its maximum, which is somewhere in the 30 volts range. So the bench power supply is at 32.35. And we can see it's still pretty close. It's as close as you're ever going to need. Let's switch that into continuity now. So I'm just going to do it manually. Bang, bang, manual. There you go. And look at that. You've got a nice visual representation. It's pretty quick. It's not instant, but it's pretty quick. And it's definitely quicker than most. So some devices, when they're measuring continuity, are doing it with a very simple circuit, whereas in this case it's going through the meter's electronics, and that can always introduce a bit of a delay, but you can see there it's not too bad at all. Let's see if we can measure a component here. So we've got an LED, so I'm going to put it onto the diode test now. We're going to split that open. Let's see what it says on there. One leg on there and one leg on there. There you go, 0.6 volts. And then turn it round again. That's bizarre, isn't it? You didn't expect the LED to actually come on, and I didn't expect it to be a multicolour one. Just had that knocking around, but there you go. So you can see. That's kind of cool, the draw through there. Well, I noticed there's a temperature measurement going on, and I suspect it must have a temperature sensor inside it, so it's giving you a case temperature. So you can see I've jury rigged it into our mains connection here, and it's reading almost 50 Hertz. I guess that's close enough for UK power. 50% duty cycle, so that's a sinusoidal wave that's nice and even. And that does the trick. And I didn't get an electric shock doing it, so that was good too. And in fact, while I was in there, I might just as well put this on the voltage for the AC again. And you can see it's lighting up the two probes here, and I'm just going to defeat the safety on the UK plug. Wiggle it around till we find something. Come on. Okay, I seem to have been a bit of a muppet actually, to be honest. All you do is when you get to this range, when it has the DC and it's not working, just press left again, and you can see it said smart up there, and then it just worked it out. And it's saying AC 233.6 volts, true RMS, so that's good. I switched it over there to current, and you can see it said lead because it's detected, and in fact I'm going to remove these from the mains while I do that. It detected that the leads are in the wrong place, so look, it's actually telling you to shift between there. And you should be able to detect current. I'll have to figure out what we can detect current with though. So you can see now I have actually turned on the lights because I figured out a way of tilting the screen. And by the way, this shroud here is lovely and rubbery, so in case you drop it, it's probably going to survive. Now what I've got here is a PC fan that's currently running at 4 volts using 50 milliamps, which is great. And you can see it's connected via these little bits of wire. So what we need to do is basically put the meter in series. So I'm going to connect this to this probe here, give it a little wrap. Hopefully it will stay put. You can see it just flopped off there like an annoyance. It's probably a good opportunity to look at this kit though. You can see exactly when stuff goes wrong. So this is all my little rubbishy test leads have started to break and things like that. So this is where these really come in. So let's have a look at what we get in this particular kit as well. And if you haven't got one, you probably will end up wanting one. Sometimes it just boils down to measuring continuity. And if you're measuring continuity from a circuit in the engine bay that's going all the way to the tail, you want these long leads. And you know, your meter can be somewhere in the middle beeping whilst two of you try to probe it out. Now you probably won't need two of you to probe it out though if you have a kit like this, because it comes with a selection of probes. So these are some of those nice little hooky probes. I'll zoom in so you can see. Very handy. These have a myriad of uses, and there's a word that I've never used before, but maybe I've never said it before, maybe I'm saying it wrong, but you can hook these around the leads of so many things, capacitors and whatnot, and just leave them in place while you take measurements. Especially useful if you're just trying to debug a piece of electronics and it's just sitting on the bench. These are some very beefy guys. Look at that. Now if you ever have to bite onto something with some force, that's your one, because that actually is leaving some dents in my fingers. I don't think I've ever seen something with such a tenacious spring, but yeah, don't play with that too much. Don't allow your kids to play with it, because it really probably could draw blood. Nice and firm there. Again, you can use those in parallel with these kinds of wires. So, these are absolutely superb as well. We might use these in the little project we're doing to try to test current. And you can see, I'll zoom in, they're very sharp. And the reason they're very sharp, and I'm going to put that back on carefully, is because these are designed to poke through the insulation. So you literally find your wire. In fact, I can demonstrate that, that's okay. So you get your wire like this, and you can poke it straight through carefully, and don't do it the way I'm doing it, which probably will end up me getting injured, like that. Well, not like that, because I was too scared, but yeah, somewhat like that. You get the point. You're poking it through the insulation, through the strands of the wire, and what you can do then is basically test it through the insulation. You're just making the tiniest of holes. So either push it right through so it stays in place, or literally just poke it through the tip. And don't do it like that with your thumb. Put a cork there or something so you're pushing in against something firm, and that allows you to test it without causing too much damage. And often, really, especially if it's low voltage like a car or something, you'll just leave a little hole and you can just ignore it. You can ignore that hole. This is very handy too. A little bit like the spring clips we saw earlier. These are the big brother. So that's your little ones like that. And that's your big brother, and that's again very firm spring pressure on that. I'm not going to do it on my hand because that's going to have too much bite. And I do like this flexible end. It reminds me of that Dr. Octopus superhero or supervillain type character. We'll come back to this one shortly. So you've got one in black as well, so you can complete your set of your biters. And there it is. Oh, there's loads of them. So there's your black version of that gripper too. So that's super handy. I could think of many uses of that. And again, these are Cat 3 and Cat 4 rated to 5 amps, so there's plenty of current capability here. So if you wanted to measure the current of something quite beefy, you can. Again, not quite sure what the leads are rated to. We have Cat 3 1000 volts written on there. 10 amps. So yeah, plenty, absolutely plenty. Let's see what else. Keep digging in here. Oh! Okay, so these are cool. So these are probes, but they've got that springy end like you see on banana connectors. So I'm just going to unplug something here so I can show you. So you remember these? It's basically the equivalent of that, so you can just plop them in there, which is quite nice for test equipment. And I think some speakers have that at the back, so you can just interface directly. Say, for example, like now, these are plugged into my bench power supply. I could use this to validate my bench supply readings. And in fact, You know the other kinds of terminals, which I can't show you, that are on the bench power supply, which are a hole, and you can just shove that straight in the hole and that'll lock in. Very handy. But I do like that when you clip this on though, it's giving you the regular tip. In fact, am I trying to over push it? I am. I'm trying to force it on too much. That's just a regular probe tip, so you could just use it for both purposes if you had to. So smaller biters, again, very tenacious, very sharp. I mean, those are probably the kind I'd use the most on things like we're doing now. So I'm going to actually keep those aside. What's in here? It's so exciting. So this is your 10 amp category 2 1000 volts, and you can see it's just totally protected. There's no little bit of tip sticking out. If you're going to use that, you are definitely committing to using that one. And let's see, there should be another one. Yeah, there we go, and that's its companion. So many, crikey. Again, cat 2s. Nice, sharp, very long as well, keeping your fingers well away from that thing you're trying to measure. So you could see you're holding them this far back. Very good for probing deep. Perhaps you're working on a television or something like that. And then you have 2 more of these. Look at that. That's a nice flexible, look, 30 volts. So these are kind of a lower voltage. And we'll just pop off the cap and you can see they've got that same sharp pin. Again, probably good for a constrained position, especially they've got that sort of bout of flex in there. I should think there's probably a spring in there, like a coiled spring connecting those together. And then a couple more smaller ones. And again, these are a finer diameter needle. So this is probably a bit better for this type of purpose on this type of gauge wire, because the other one was a little bit thick. It would work, but a bit more work to get it in there. But you can see, yeah, you can just basically shove that in and measure against that. So we were trying to measure current before. I think we should resume that. Right, so the yellow wire is positive because we have a positive reading, so that's good. So what we can do is set up to measure current. I'm going to admit, I couldn't figure out the current situation, so I decided instead I'm just going to have a look inside. Just in case I managed to somehow blow the fuse on it. I'm pretty surprised if I did, but I'm curious anyway. I did discover it does have quite a nice kickstand too. It doesn't help though in the filming of this video because the angle means you won't be able to see the screen, but that's fine. And I noticed on the back it does say the temperature range is -10 to 50 degrees C, and I don't know if that's the temperature of the internal probe or the operating temperature. I suspect the latter. Now I did have a flick through the book while I was messing. It does have live voltage, and it uses the red probe for that. It's pretty cool. Oh, so I guess to undo the battery, look, you just take that one off to get to this part, so you don't need to undo all 4. Those are the fuses. Now I'll need another multimeter. It's multimeters all the way down, I'm afraid. That's my little beeper. Fuse is good. Fuse is good. So it's just me. I'll have to have a look through the instructions again to see why it's not measuring the current, but that's fine. I wonder if I will be able to just prise this apart. Just sensing for hidden screws. I'm guessing not. No, wait. Oops, hello. It is starting to. I mean, with the help of a spludger, I think I could get in there. Work my way round. Yes. And you can see it has that rubbery protective finish, which is quite nice. Come on, come on. It is quite firm. It's weird how it doesn't feel like it wants to go. Oh, hang on a minute. I think it might have a reason not to open because you have these fuses here. So maybe I better pop those out. Right, so I got the fuses out. That was indeed what was holding them, and they are marked. There is a 630 milliamp and a 10 amp fuse. Being a bit ginger because we do know there's a light on the back that's connected somehow, and I can disconnect that. And there you go, look at that. So, interestingly, that wasn't the light that's connected. That is the battery. The battery's in there. Look, in that little area there. That's fantastic there. That's the main board. So let's have a look while we're here anyway. You can see the bottom of your contact. It's nice and clean in here. SDIC, SSR, SD7502, that's your processor. And that's basically all she wrote. On the other side, you're just going to get these buttons, just these contacts. There'll be nothing to see. So it's nice and simple. There's your beeper. I suppose we've come this far, we might have a quick look at the battery. Now I'm really curious as to what I'm doing wrong on measuring the old current. Here we go, the moment of truth. Yep, exactly as you would expect. The regular kind of battery. It's 4.44 watt hours at 3.7 volts, 1200 milliamp hours. So how long that'll last in such a meter, who knows, probably a long time. They don't tend to use too much. I didn't notice actually if there's any relays. I mean, this is that I don't think that's a relay. What does it say on it? It says 30 volts DC, 0.5 1 amp at 30 volts, half an amp at 125 volts. Yes, that is a relay. It's a little micro relay right in there. So we might hear a little click when you're using it. That'll be that. Right, I'll pop it back together and try to figure out what I've been doing wrong. I will say something. The fit, finish, plastics, everything on these are absolutely fantastic. I'll admit it, I am the biggest idiot that ever lived. Now, let me just show you how I've got it set up. So I've got it set up in series with the fan, and you can see it's currently measuring 4.6 volts. I'm actually putting out 5.2, but it's obviously losing something in the old coil. And I wanted to measure current, right? So I couldn't figure out why it was going wrong. So what I did is I manually drove this around to the current mode. And by the way, it automatically switches these modes as you switch the lead. So if you put the lead in the current sensing mode, it'll actually put the meter into the mode. So you can set it by the meter or set it by the lead. And then I noticed these two flashing because I had the probes in the wrong place. So now I'm going to put the red probe over here and you can see the bloody fan running. Because I'm an idiot! It literally illuminated the contact points to use. However, I didn't see that because anyway, that's just me. I'm going to claim I don't measure current very often, and so I don't. And you can see here it's currently saying 61 milliamps, and I can confirm on my bench multimeter, which is an ancient Thurlby, it's reading 67 milliamps, so it's pretty much close enough. Now I'm going to wind that up a little bit, see if I can get it to, I don't know, I'm gonna get it to 100 on the bench, so it's almost there now. Just doing the fine adjustment. 99, one little breath of on the fine knob there. Come on, now it's at 100, and we're reading 94. So I wouldn't know who to trust, but I think it's pretty much close enough for most applications. Now, great, all fantastic. I feel I'm redeemed. Let's cover this last bit of probage here that's in the bag. This is really cute. If you do a lot of surface mount stuff, obviously you can plop those in, and you've got these little tweezer probes that you can just put on either side of the little connectors. Sorry, that's connectors. Well, you can put it on the either side of each connector or components on your surface mount. I shall give you an example here. Look, you've got a capacitor, and you could just do that, and you could measure the voltage across your capacitors. Nice and easy. That is pretty cute. I may well be using that in the not too distant future. Right, I'm going to just put this meter aside now because I feel we've dwelled deeply enough on that. And it certainly covers all of the features you're ever likely to use. I'm going to put these back on. Don't lose these, by the way. They are super useful. You don't need the probes normally on their full unprotected length for most things. So this is the KC602 smart clamp meter. Now, a meter is a meter is a meter. And by the way, the manual did come in quite useful. Study the manual if you're interested. It has a lot of features you want to know about. So clamp meters are particularly useful, and I do have a little collection of them because they tend to be quite multi-purpose now. So as you'll see, this will not only do clamp metering stuff, but it will do regular metering stuff. I'm going to push the power, not coming on because it does come with supplied batteries, so there's no batteries in it. Let's get on that. These are Kendall. I suppose we might as well use them. I think I'd be more inclined just to use some regular Amazon alkalines, but I don't know, we can trust the manufacturers, they do the job I suppose. Plop that in. It's having a bit of a beep at me. Now the probes are smaller versions than the ones we've already been playing with, a little bit shorter, probably better to fit in the packet. But look at that, it's got the same display. Now I did notice that on previous Kaiweets meters, and that they do tend to have a standard interface. Now the older ones I had the regular kind of basic interface, and these ones seem to be of the range with this fancy glowing screen. 600 volts Cat 3, it says it's rated to, and it does have the same visual indicator there. I can see that definitely would flash there when you're holding it up. You got the torch as well. Going to hold down the button. Yeah, all the good things. They're almost becoming the minimum standard, aren't they, for these particular Kaiweets brand ones? They always tend to have a torch in there. So you have an auto function, which is nice. Max min, select an inrush current, and at the bottom you've got your COM and your input, your black and your reds. In fact, let's just chuck them in while we're here. I almost feel bad having so many sets of leads all over the place. Now I always tend to lose these things, but that's because I don't tend to keep things in their cases. They're sort of draped on a shelf in the garage, covered in oil usually. So we got the red input and the black input, nice. And you do have the same thermocouple type tensor probe. We won't be going into that, so let's put this aside. Now I'm not going to bother going through the same features. You can see here it has current, voltage, resistance, continuity, diode, frequency, capacitance, temperature, and the NCV live, and that's the live mains detection. I'm not quite sure if it's doing it from the probe or if it will be doing it from the end here. It might be a variety. In fact, I've just noticed something that's quite cute too. It has a clip. That's probably why it has the smaller probe, because it has the clip for the probe here. So that's good for your single-handed use, because sometimes you do, if you've ever used any of these kind of meters where they're basically single-handed use, it can be handy at times. And also it can be really annoying at other times, so you've got the choice. The bit that interests me the most though is this clamp meter. Now, normally when you're measuring current, you could see we had to do it in circuit. That was baffling me for a while. This allows you to hook it over one of the conductor wires, and it will actually just measure it. So if you put this on the pigtail in your cupboard around your mains cable, one of your mains cables, it'll tell you how much your house is using, which is great. But this one can do DC, or it's claimed to do DC, which I thought was kind of cute, because we have this set up right now with this guy spinning here. I would like to try that, because DC requires, the problem is because DC doesn't produce the same magnetic field in the wire, you have to have something in your sensor to inject a field and then measure against it. I don't know how it works. It's basically magic. So I'm going to take one of the wires here, which is going to be, I guess, our positive. And the nice thing is, of course, you see, if you want to measure something and you don't want to be in circuit, actually, it's already measuring some sort of current. Did I just get that right? Hang on, I'm just going to undo it. No, I think I was just going mad. I just haven't selected the right. So I've got it hooked up. I've set my bench power supply to be a bit more beefy. I really want to give the fan a bit more juice. So you can see we've got these all arranged now. So on goes the fan, and we're drawing around 230 milliamps. And you can see here on the right, you've got your 225 milliamps, and here a bit high, 350 milliamps, but you are doing it totally without doing anything with the cable. So it kind of depends on what you expect your range to be, because if you're literally measuring down to the like for now where it's about 100 milliamps, you can see the accuracy of this is going out, but here it's pretty good. However, I think you could argue that at least you are getting a measurement, you know. And as I crank that up and down, you can see it is using more current, less current. I think I'm actually burning out the fan. It says here the minimum identifiable DC current is 0.8 amps. And the minimum identifiable AC current is half an amp. So yeah, I don't think that fan's cutting it for the detection. That probably accounts for why we could see that variation. Yeah, we were definitely using it correctly. By the way, that's a handy thing. When you are measuring, you have to measure the individual conductor. So put it on the live or the neutral or the positive or the negative. Don't do this where you're putting it around both, because they cancel each other out and you'll read 0. Armed with fractionally more information because I read the appropriate section of the manual, I've since learnt that there's a 0 button for DC. So you really apparently have to hit that, otherwise it's not going to do what you need it to do. So now it says DC and it's kind of zeroed, I guess. Maybe you have to hold it down. It's fine. There you go. Yes, you did have to hold it down. Let's put it on there now. We're trying to aim for 130 milliamps. That's what the bench power supply is telling me. And it's telling me it's around 200, 180, 170. I'm going to call that a win. And the reason I'm going to call it a win because the manual clearly stated that this is kind of under its measurement range. Probably if you were measuring your robot on Robot Wars or something like that, you'd get something a bit more accurate. It does have the ability, of course, to do the NCV measurement. I'm guessing that's non-conducting live voltage, which it's on now. You can hear it beeping, and that's because it's detecting the voltage in this general area. Now, as I move it around to the main sockets over here, so you can kind of hear them going. It's basically acting like a radar. The closer I'm moving it to where a main socket is, it's starting to beep. You get a little warning there, and then away. Now, something I do notice with this, again, it could be down to accuracy. I have some lights here, and for whatever reason, any of these non-contact measurement systems go nuts with it. So it's putting out some sort of crazy RF interference on these things. However, generally outside in the normal operation theatre, they work pretty good. So I like this. I think that would fit nicely in my pocket. Again, it's compatible with that same lead set, so everything would work the same way. So depending on what really the types of measurements you do on a day-to-day basis, you could choose between these meters. I think personally the most common things you're going to use as a hobbyist electronic guy, you're going to get absolutely great value out of this one. If you really need to do the non-contact measurement of live mains and you want to detect that current again with a clamp meter, yeah, it's a no-brainer. Obviously you need this, but yeah, I think if you're just going with something you don't have anything right now, I think £45 for this is an absolute bargain. Would I recommend you get the cable set? Again, that's up to you. If you're planning on taking this up as a hobby, or you're using it professionally in any capacity, I think that these cables are going to be really useful to you. But if you're on a tight budget, yeah, don't worry about it right now. I mean, I've gone decades without any fancy cables. I mean, I did used to make up some of my own. I can show you what they look like. I mean, they're a bit crappy, but they do the job. Would I wish this on anybody? Probably not, but you can see what I was getting up to with this. I've just basically can poke these in breadboard and use these little clips. You can buy all these clips online. So contemplating on whether or not I will use either of these to replace this my daily driver, and I will say the jury's still out. This one is quite neat and does fit in my pocket, so that'll probably still be a go-to. However, I do tend to leave this on various lab benches and even in vehicles from time to time. I think what I will do is I will set this up on my bench, because I've always wanted a bench meter that's been reasonably permanently set up, and I think that this kickstand on the back allows it to do that in my particular setting. And the lead kit here really lends itself for that, so I'm probably going to make some space here and have all the leads arranged and this set up nicely, and then if you still need it on the move, you just grab it, off you go. So I might leave the case with one set of leads, and then just use these on the bench basically like that, and then take the meter if I need to. And then for my automotive use, I think I'm going to keep this in the automotive toolbox, because I really like this current measurement thing. I'd be quite interested to see if you can measure cranking amps. It says it does 600 amps. I don't know if that's realistic. I mean, I'm not really sure what a car battery draws when it's cranking. It might be more than that. But certainly you'll be able to monitor electrical systems in vehicles when it's running. And because you have that common ground, you always have like a live wire going to anything. So it's quite easy just to hook that around and just see what's going on with things. And of course the probes and the temperature thing make it useful for that too. Like if you occasionally want to see if your thermostat's opening at the right temperature, just plop that in to your radiator water and see what happens. So yeah, I think that's what I'll be doing. What would you do? Would you want any of these, or would you be, nope, I'm absolutely not interested in meters? Please comment down below, like, share, subscribe if you're interested, and come chat to me on Discord. Thank you for watching.